Alright then, so setting up components into the MV10. Now then, before we do that, we're going to be setting up a reel of components, okay, showing you how to install a reel and getting the tape fed through. But before I do that, we need to discuss tapes, because tape is quite important. If you get the wrong tape into the wrong feeder, it's not going to work. You're not going to be able to pick and place your components. Your tape will either get stuck or it won't be fed through. And yeah, if you get the components wrong, okay, if you input the wrong size of components, it's not going to pick up, and you're not going to be able to work out what your feed rate is to present your components. So, first up, got a strip. Holes along the top are called the sprocket holes. The pick and place machine uses the sprocket holes to advance the tape down the lane, okay, into the feeder channel where your tape sits. Also uses the sprocket hole to align the tape to present the component always in the same position for the pickup head. So this distance you need to know is 4mm. So every time you advance the tape manually, you're advancing in 4mm steps. Next thing that you need to know is your carrier pitch. The carrier is what your component sits in, and you need to know the pitch because the carrier pitch, or your component pitch if you like, sets your feed rate. That's where you get your feed rate from. So wrong feed rate, the tape will pass through incorrectly at the wrong increments, and you'll end up losing components, or components won't be presented correctly, and the pickup head is going to pick up the component in the wrong positions. It's not going to be able to identify it because it's in the wrong position, maybe the wrong angle because it picks it up and it catches the side of the machine or something, or it may not even grab the component at all. The nozzle might just hit, can't create a vacuum, doesn't pick up the component, and it just fails placing your board. So feed rate is very important. Also important, dimensions of your tape. You can get tapes in different widths. This one is a 8mm tape, but you can also get other widths of tape, like which I haven't got there. Let's see, which is this one. Okay, I've got some ICs there, SOICs on the small reel. They're actually 12mm. Okay, tape width is 12mm. So that's very important, like I said. Wrong tape widths, yeah, you're just going to jam up the machine if you force it into a carrier that's too small, and if you put too small in one that's too large, it's not going to feed through, obvious. So let's take you through installing a reel first. And then I have to apologise for this, tripod has gone walkies, so I'm going to have to carry the camera. It might be a little bit shaky and in parts, and I may not be able to get right in there as much as I'd like, but yeah, you'll get the general idea of how to fit a tape into the MV10. So let's get going. So got a couple of reels. I'm going to do shall we do a plastic reel or a tape reel? Let's do a tape reel. So these are 10 picofarad capacitors, 5% tolerance. It's on an 8mm reel. And the first thing that you need to do is to measure the dimensions, so in order to set your feed rate. So what you need, pen and paper, and a micrometer, or a set of calipers or vernier or something. That one will do it. There we go. Right then. So got something to measure my reel with. So my reel width, we switch this on, make sure that you're working in millimeters. When you get one of these, make sure position is at least up to 0.01 or something like that. You don't want to go any lower. So nice and zero. Then we start to measure this. So peel off your plastic leader tape. Keep the sticky end, that's important. Reel off a couple, and a couple of loops and start measuring. So sprocket width is, if you measure from the bottom of the hole to the bottom of the hole, that should always be 4mm, which it roughly is. Whoops, I just knocked it back then. There we go, it's roughly, there we go. It's not exactly accurate because I'm doing this quite quickly. Yep, 4mm, close enough. But what's important is your carriers. Now when you measure your carrier, on the data sheets it shows you from the centre of the carrier to the centre of the carrier your pitch for your feed rate. I don't like doing that because trying to get to the centre is, you know, it can be quite tricky. It's going to be a large error to that. So the easiest way is to measure from the bottom of one carrier. So go from the bottom edge down here to the bottom edge of the next one, which will be, in this case, again 4mm. You can see that from the bottom to the bottom, about 4mm. So we need to use a 4mm feed rate. Now when you're programming feed rate, you have to program that into the actual lane itself, into the feeder tray where all your reels are installed. So let's get into the machine. We know our feed rate, we know it's in 4mm advances. Let's start plugging this in. It's going to be the tricky bit. Alright then, so these are your lanes where you install your components. Over on the right hand side of this, you've got your controls for setting up the actual address of the lane and the feed rate of the lane. Now the basic controls first are the upper one selects the lane and the lower button advances the lane. That's the basic controls. If you want to set feed rate, you have to push both buttons together and then it comes up with a letter A, and you have to do a combination of up, down, what have you, in order to set up your feed rates. That's a little bit awkward, so I'm going to leave that to the end and take you through that. I'll also take you through another double press and then another combination to set the lane address. But for now, let's feed the components in because that's going to be the awkward bit. First things first, when you have your component reel and you've peeled off your tape a little bit like that, keep the sticky end, and you want to stick this back against the tape. So lay that back against the tape, make sure it's not twisted, and then use the sticky end and the sticky it back down against the actual tape. So there you can see it. So they're my empty carriers, there's my tape, and it's fed back on itself and stuck back to the actual tape. You want to do that so that this tape, the plastic cover tape, doesn't get stuck in all of the rollers and bars and clasps and what have you when you're feeding the tape through the machine. If this gets twisted and damaged, then it makes life a hell of a lot harder to feed in a reel. Next thing that you do, once it's stuck down, bend the end of the tape up, because as you can see it naturally wants to sag downwards, but you want to feed your tape in an upward position. So if you bend the end of the tape up, when you place it into your holder, this is caps, so caps on this side, it feeds upwards. So you want to feed in your tape, feed it upwards underneath the roller. I had that once, it's not going to go now, is it? It'll be a bit of a git to do. Okay, so you want to feed it underneath the tape roller, right at the back here, this little thing. That keeps the tape flat to the bed once you slot it in. So you just slide the reel in, the tape is fed through to the opposite side. Next thing that you have to do, this is tape that's been fed through. See this tape, you can see my sticky tape on the top. It's in the rails, it's been fed underneath the, this is the plastic tape take up, so this is where you'd attach your plastic cover back to, but that's the last stage. So take your tape, you want to feel it underneath the feeder bar just at the back and into the guide, into the feeder guide. Push it forwards so it's in, it's nice and smoothly in the row, all nice and lined, it's square. And the next thing that you want to do, once it's in the rear, if you can see down the back, it just goes underneath the feeder clasp, or your tape clasp. You need to set that next, so around to the opposite side. Now then, the tape clasp basically holds the tape in place for the when it exits. Okay, so it keeps the tape nice and flat, and it keeps the tape flat against the advanced pin, because you've got a pin that sits into these sprockets and it pushes the tape forwards. Without this in place, it will just push the tape up and it won't advance it. So what you have to do is try and feed this tape underneath these clasps, and in order to do that, so let's put that one in back in. Raise the back of your feeder, slide your tape underneath. This can be tricky because you've bent the end, it can be a little bit of a getting this under. Alright, and so what we want to do is to lift up this clasp here, slide our tape under, and we can push it all the way forwards. Once it starts stiffening up, push back on the clasp because it's now pivoted, so you can see the front of the clasp coming up. Keep easing the tape forwards and you can just see it coming out of the end. Keep pushing through and through until your sticky tape is all the way through. Now the sticky tape bit is the most awkward part because it's going to stick to the rails, which is going to be a bit of a git. Slowly feed this through. And there we go, so you can see the sticky tape coming out now. Try and do it from the opposite side, so keep pulling this through. Yeah. Make sure that it is pivoted. If it drops back in, just lift it up a little bit. Keep pulling through until the tape's fully through. Once that's through, take your tape. Whoa! Unstick it. You want to pull this tape all the way back. You will lose some components at this point. It's always inevitable, but since that you've got reels of 5,000 on these caps, you know, half a dozen or so isn't really going to make that much difference. So we've peeled the tape back under, and then we can place that into our tape pickup reel, which is back here. So at the reel end, this is going to be the most awkward thing to do in the world because it's one-handed again. Get your sticky tape end, stick it to the reel. Doing this two-handed will be a hell of a lot easier. I just want to stick this down flat and then wind it so that the tape sits under the reel, making sure that it doesn't twist up. If it twists, try and get the twists out, otherwise your tape isn't going to lay flat. So take it round, if I had two hands free and I had my tripod, I can show you how to do this properly, because the ideal way would be to pull this tape up slightly and keep tension on it, and then reel it on under tension and you won't twist the tape. Okay, so like that, so it's nice and straight going into the reel. Unfortunately I can't do that. It's a bit of a git really, so it makes reeling these on that a little bit more difficult, but there we go. So our tape's on there, as you can see. It's a little bit twisted here, but that's because we haven't put it underneath these little hooks yet. So just lift out your tape and hook it under so it's nice and tight. And try and keep all these tapes on top of the clasp, that way they won't snag and catch. And there we have it. So that's our component strip there coming out. What do we do with the excess? Well, take the tape and stick it in the exit tray. Now you want to bend the edge of the tape back on itself a little bit because it curves back on, so push that down, under, and that exits at the bottom of the machine. Yeah, so you can see our components are presented, but if you take a look at all the other lanes, all the other components, all these components are aligned in the same position, whereas this one isn't. So what you need to do is you need to advance the lane in order to align the pin to the sprocket holes, and it will align all your components to the same position in increments of 4mm. As you can see, the other tape drills are exactly the same. So in order to do that, you come around to the rear of the machine. The tape that we just installed is in lane 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we need to adjust our digit to lane 12. Now this is only a single digit, so it will go up to 9, and in order to display the 10 and above we get a .0. The dot means a 1 on the MV10, so .0 means 10, .1 11, .2 12, and so on. We were on lane, what was it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, yeah. So lane 12 is .2. Then if we press the bottom button, it should advance the tape. So if we take a look around the front, when you press this bottom button, you will see the tape feed. There you go. So it's done it to 4mm, and we got our components all in place. So a bit of crap on top of the bar, looks like it, yeah, just a cap. So let's get rid of that. So every time you advance now, it does it in 4mm. And as you can see, because the feed rate is 4mm as well as the advanced 4mm, the component's always been presented in the same position. Excellent, thumbs up. But I'll show you how to set the feed rate. So that's what we'll do next. Alright then, setting feed rate. What you need to do is to press both of these buttons at the same time until the letter A appears, and there it is. So we've got an A on the display. Next thing what you need to do is to go top button, the upper button, P will be displayed. Then you press the down button, this will start flashing. So this is telling me that I'm now working on these lanes for the feed rate. Next thing that you do is to press the upper button, and it takes you into the lane settings. So this number up here is saying, right, I want to change the feed rate to lane 1. I don't want to do that. I want to say do it to lane 12. So 2, 3, 4, 5, 6, 7, 8, 9. Dot 10. So dot 0 is 10. So dot 2 is lane 12. So I've got lane 12 selected, which is our caps. After doing that, you press your bottom button, and it displays bars now on the display, and the bar sets your feed rate. So it depends on where the bar is positioned, or you've got double bars and so on. You can set the feed rate. The feed rates are, I think, are in 4mm, 8mm, 12mm, and so on, up to I think it's about 20 or 24mm on the feed rate. That's all coded in using the bars. What I'll do is I'll flash up the this particular decode table, as it were, right now. So there it is, and we want to set this to 4mm, which is what this is actually set to, the centre bar. But you can change this. Cycling the bottom button can change the feed rates and so on. When a dot is displayed, that is in slow mode, so if you've got particularly delicate components, they're loosely held in these carriers, in the strips and what have you. You can do it slowly so they don't actually jump out of the carrier or anything like that. So that's what the dot's for. And you can dot anything you want, but we want the middle bar for 4mm. If you're happy with that, you press the upper button. This takes you back into the lane menu. Cycle it through to 0, so lane and nothing, so we're out of the lanes. Lane 0 is the important one. Once you've done that, bottom button, little naught appears and it flashes on and off. That's our feed rate saved. That's how you do feed rate. If you change these, the whole reel holder and whatever, you want to put a completely different one in because you have more than one, then you need to make sure that you set the lane address. This lane is lane 0 on this side. In order to set lane addresses, again, push them both together, letter A appears. Instead of the up button, you press the lower button this time. You press the lower button, the A flashes, and then you can press the upper button and you can cycle through the different lane addresses. This one's lane 0, so make sure we set this to lane 0. Once you're happy, press the bottom button and it's saved. Again, simple. So that's setting your lane address. So this particular lane is lane 0. This lane over here will be lane 20, the feeder, that will have a different lane number. Carrier doesn't have a lane number because you manually place that yourself. That's something that you set up in the software to say your components in the component feeder, this is where the feeder is and so on. But the lanes are addressed, and likewise you've got another position for another feeder or whatever, tape feeder or a real feeder or a vibratory, and the other end that'll have another lane address. Important thing is to not conflict the lanes. Make sure that the lane addresses, they are different. If they do, if they are the same, you will conflict, and the chances are it won't pick up components, or pick up components from the wrong lanes. So it's very important to set that. And basically, that's how you set up a component reel in the MV10. Next thing, everything in software now. So we need to set up that component in the library, in the MV10, the Mechatronica Pick and Place machine software. So let's get that up and running. Right, so while the machine's going through startup and setup, what I suggest you do is to take one of your components and measure it. The most important thing about your components is measuring the height. Without knowing the height, and your heights do change between manufacturers, component values and so on, heights will change. Without knowing the correct height, your pickup head isn't going to lower down low enough to actually pick up the component, or it's only going to come down low enough, and it's the vacuum that sucks up the component and it can twist it out of position. So make sure that you know the height so the pickup head picks up the component correctly. Other things that you need to know is the length and width of your component. So take your device, measure it. You can estimate the length and widths. That's not as important as the height. So if you know what your package is, say 0805, that's what these ones are. It'll be 2mm by 1.2mm. If you're not too sure, then measure it. Height, always measure. Can't stress that enough. So let's switch on our calipers. The height of our component is, grab hold of it. Okay, it's about 0.5mm for a 10 picofarad capacitor. Obviously, the larger the value capacitor, the higher your component is going to get if it's in the same package. If you go for a different size component, say next size up, maybe the 1206s, then again it's going to have a different height and a different width, so you're going to have to remeasure all over again. All components have different heights and sizes, so make sure that you measure it and you do note it down. So this is the software for controlling the machine. Basically you've got board, first option, board. This is where you set up your board. You show it, you train the camera on the fiducials and you set up the board size. Program, that's where you run your program for. So when I did that demo last time, this is a program that I run, it's placed in a single IC. Feeders is where you set up your components. You can only set up components in here once you start doing the library. System gives you information about the system and so on, and logs. Log is all about what boards you produced, how long the machine's run for and so on, what components have been placed, if there's been any errors and what you're not. So what we want to do is to set up our component, because we just installed a rule, so we want to do that in the library. So we go up to the top, hit library, open up the library, and it presents you with various components that's already been installed in the machine in the past. Some of these are demo ones. This was an ex-demo machine, so it has had some other components placed into it, like 1 meg 1% and so on, or 2K2s, what they used in the demonstrations. For here, I've placed all of our components underneath the lab reels. So 0805 capacitors, 0.7 height, 0805 capacitors, 0.8 height, but that capacitor which we just pulled out was a capacitor which was a 0805 cap, 0.5 in height. So we need to set up a new footprint. I need to kneel down here. Right then. So, in order to do that, first of all, when you add a component, you can either create a folder or do it in the main root menu if you want. It's entirely up to you. Right click on the folder and select new. Like I said, you can do new folders or package types. So we want to do a new 805 package because it has a different height to the other ones which have already entered. So, right click, new package. Let's give it a name. Try and stick to a convention of some sort. The convention I'll go for is the footprint, which is an 0805 cap. It's a capacitor and it is 0.5 millimeters in height. So that's what we're going to load this one under. That's the actual package. It presents you with the specifications for your package. So you need to tell it the length and width. Length of my component is 2 millimeters and my width is 1.2. that we've already measured, which is an 0805 package, and my height, important one, is 0.5 millimeters. If you're using diodes or electrolytic caps or chips or anything like that, you can select the polarity option and you can specify where your dot or line is on your chip, so you can align the chip. As a generic ceramic cap, that's not the case, so we don't need to do polarity. Once you've got your measurements in, go to pick and place, and you want to set the nozzle. Everything else can stay the same. Your package tolerance, that's the tolerance in the actual package in the strip, so it can be plus or minus 10 degrees, and it can be out of position by up to a millimeter, and the camera will try and find that within that tolerance and then realign it so it's square. Nozzle is the most important one. This is an 0805 package, and that nozzle is in nozzle number 3. Nozzle 1 is my 0402, nozzle 2 is the 0603, nozzle 3 is 0805 packages, so select nozzle 3. You want to select the largest nozzle size for your component, so if this was a chip, then I'd pick a nozzle size that will cover the chip the most. That way you get a nice decent vacuum and the chip isn't going to move about on the nozzle. So select nozzle free. Motion speed, this is the actual pick and place speed. So you've got fast or slow. Slow for extremely large packages, fast for the smaller ones obviously. Disposal method. That option is either dump or give back. That's if the camera doesn't recognise your component when it does the image recognition part. If it doesn't recognise the component, thinks it's picked up the wrong one, you can either tell it to dump the component, so it'll dump the component and go and pick up another one, or you can tell it to give back the component if it's an expensive device like a microcontroller or something and you don't want to waste them. So you can tell it to give back, it will pause the machine, give you back the component, and you can re-put it back in the holder ready to use again if you want to. So you can do give back. Pick up and place delays, that's how quickly you want to pick up and place, so that's the delay after the nozzle has attached or wants to come off your component. So in order to pick up the component you need to create a vacuum. If you don't create a vacuum long enough, it's not going to pick up the component. Likewise, if you don't dissipate the vacuum, which is your place delay, for long enough, it will suck the component back up off the board because it hasn't dissipated the vacuum. That one should stay the same, 20 and 40. You only need to change that for your larger packages, and you can play about with that yourselves. Overstroke is if you want to push the component down into the board more firmly. So you overstroke it, you force the component down onto the board by so many millimeters. That's if you really want to squish the component down into your solder place so it's on the board tight and you don't want it to move about. Just bear in mind, if you do overstroke, you might squish your solder place outwards, so you might end up creating shorts and things like that. So it's a trade-off sort of one. Normally you set that to 0 so the components just sit on the place nice and neatly. Once we've done that, pattern match to the bottom camera. Learn it. You can't learn it yet because it's not set up in the feeder. That's what we do next. So add our components to library. Yeah, hasn't been trained for optical centering yet. Yeah, fine, because we haven't set up the component in the software in the particular feeder. That's what we do next. So OK out of this. We've got our component there listed in our library. So we need to set it up in the feeder before we can go back and redo this component again and make all the various changes. Do I need to do anything else? No, I don't. Right. But polarity is off. Make sure that. Okay, there we go. Yes. Okay. So, into our feeders menu. Now we're in lane 12, so we want to highlight lane 12. Right click, set pickup position. We want to teach in with the camera and select teach in, so get the crosshairs. This is our camera at the moment, our look down camera. Over here we've got the controls to finally control the head. What you need to do is go to the quick jump menu, and then you can move the head around the actual, this is the pickup area, pick and place area. Blue crosses are where components are, where positions have already been set. Red crosses are fiducials, which are already set up for a particular board that's in there. They'll change for when we place our board though, so you can ignore those. So our pickup position is going to be somewhere down here, above these 4 caps which are already placed. So if you click on the bed, there we go, that's in lane 13, so lane 12 is up here. This is the one that we just installed, just to make sure there's no taping the other one. No, that's our next lane. So what you need to do is to align this box to your carrier. It has to be square, so squidge down the box to the edge and squidge it down so it's it's almost centre. Come out a quick jump and you want to fine adjust the position so it's centred, then readjust your box so it's just inside the carrier. So it's going to pick up the component in the centre of that carrier, right in that position. So let's go to the, whoops, oh dear, that wasn't good. There we go, back to the centre, align it to the edge, and OK. And on lane 12 we've now got our pickup position X and Y set. Next what we need to do is set the Z height. So I've already set the nozzle, so it knows what nozzle to use, and we can select pickup height. So then we want to measure our pickup height with the with the nozzle, and okay, whoops. I'll do pickup height. I did do pickup height. Yeah. So measure. Okay. There we go. And you want to move the head using the look down camera to a section of the tape where a component doesn't exist. Now if your component is in level with the tape, you can set it on the tape. If it isn't, then I'll explain what to do next. So providing that the top of your component is at the top of the tape, move it to a section of the tape and click OK. Pick up the nozzle and it will automatically bring it down, and when the vacuum sensor detects a touch on, it sets the height. It does that very roughly and then it does it very slowly. Okay, and our height is 1518. If the component was slightly lower in the carrier, then we can adjust that manually and add on an extra couple of digits to tell the head to go down that little bit lower to the component. Once that's all set, we know the height, we know the things, we can go back into our library, select our component, edit, and we can do pattern matching. So select bottom camera, and learn. Using the bottom camera to look upwards at the component, and as you can see it's found where we're working now. You can say lane 12. Our part orientation in the tape, we can change that, so we want to change that to 90 degrees because it's upright in the tape, it's vertical, it's not horizontal. Or is it horizontal, not vertical? It's one or the other. Yeah, it's up. We want this to be orthogonal. So 90 degrees. Next, picks up the component and brings it over to the camera. So this is looking underside of the camera. Adjust your brightness and what have you, so you can clearly see the image, contrast, power, and whatnot. And it uses those settings to recognise the component. First thing what you do, rotate your component very fine, so make sure it's seen fine, and rotate it until it is square. You can see it slowly rotating so it's square. Then we can move the camera up and across to the component, and there we have it. We've got our component nice and square. Open up the window slightly so you've got a nice bit of space around the outside so it can look the component in that window. And we have it in the window all square. Okay, that's our component. If there's any markings on the underside of the component, you have to mark those out. So you can do that with rectangles, polygons, circles. Basically select one of these and draw a box around where you want to mask out particular areas. That way when it trains the camera on that, so if it's got a serial number, that changes on every component. You don't want an image recognition to a serial number, you want to do it to the actual pattern so you can mask out areas. Next up is still in the training mode. And this is basically running a test to actually make sure that the pattern that we just took matches the component. So run test, it's a 100% match. You can change the drift and the angle slightly, so let's do that, run a test, and it still finds it and it matches it 100%, so it can find a component if it picks it up slightly not square. So brilliant. Finish that. Now are you sure? Yes. Discard the component. That's our image. Okay, that's our component. Okay, and now we have our package defined 0805 cap, 0.5 millimeters high. Next, we want to right click on our package, new part, and we want to define a part. Now, the way how I normally define parts for capacitors is in lowercase 100 picofarads, 1 nanofarads, and so on. Resistors I've gone into a little bit more detail with the resistors, 100 ohms, the 1%ers and the wattage and so on. But for this one we would just say right click, new part, and we say it's a 10 picofarad capacitor. Okay, that's our 10 picofarad, and it's been set up in the machine, ready to roll. Nothing else to do. That is how you set up a component in the library. Bit long-winded, but once you have your actual footprints in here, it's just a case of right click the footprint, add new part, give it a value, and then in the feeder load the component. So we have to load our component into the feeder, browse library, there it is, 10 picofarad, okay. It thinks it's that way around, it isn't, it's that way around in the feeder. You can switch on quantity tracking, so if you've got 5,000 loaded, you can say load 5,000, and you can say set off an alarm once you get down to, I don't know, 100 or something components left. That tells me that I have to change the reel. So it will halt the programs, it'll allow me to change the reel, sort stuff out, and continue again. So 90 degrees it, because this is how it's in the feeder. So in the tape it is vertical. Okay, and there's our component. It's at 0805, 10 picofarads in lane 12, rotated to 90 degrees because it's vertical, XY coordinates in Z. And that is all ready to go into the program, which we can place aboard. And like I said, if you have any other components, they're once you got the patterning, the actual footprint, then it's very easy. Just tell it the value, whack it in the lane. So feed your tape in to say lane 11. You set your pickup point. You go into the library, you add your component, so there's new part, so 22 picofarad. Okay, right click, load the component or change component, and done. So once the components are in there, you built your library, it gets easier and easier and easier and quicker to actually, set up the machine. And that's how you do a tape. I'm going to finish it there because we've been jabbering on for absolutely ages, and next time we'll do the tray. Tray is a lot easier to set up, but you need to, there's a little bit more faffing about with setting up a component, because you have to use the look down as well as the look up camera, because it has to find a component in the tray using the look down camera. So you have to train it looking down and train it on the component looking up. So I will leave you there, and I will see you next time.